Okay, in 2.9, we're talking about parallel and perpendicular lines. I'm going to go ahead and graph these two lines. They're going to be parallel, but we're going to look at them after we've graphed them to see what parallel lines look like and how we can tell they are parallel looking at their equations. So for the first equation, the y-intercept is -5, so on the y-axis, I'm going to go to -5. Okay, my slope is 3/4, so I'm going to go up 3/4. And I'm going to go ahead and draw that line in, and I'm going to go to the second line and graph it on the same axes. Okay, so for the second line, the y-intercept is +1, so on the y-axis I'm going to +1. The slope is 3/4, so from the +1 I'm going to go up 3/4 to get another point on my graph. And I'm going to go ahead and draw this line. Okay, these are parallel lines. If you look at them, they're running the same direction, the exact same direction. Even if they went forever and ever in each direction, they would never intersect. So the definition of parallel lines is that parallel lines are two lines that never intersect, no matter how long they extended. Okay, now I'm going to go ahead and look at the equations to tell how could I tell they are parallel looking at the equation. This is y equals 3/4 x minus 5. This is y equals 3/4 x plus 1. So where do they match? They match right here at the 3/4 x. That 3/4 represents their slope, and they have the same slope. So if they are parallel lines, they have the same slope, which is what makes them go the same direction. Okay, so for the next step, I'm going to write the equation of another line that is parallel to the previous two. Okay, so if I want it to be parallel, it has to have the same slope. Since this has a slope of 3/4 and this has a slope of 3/4, I'm going to write an equation that has the slope of 3/4. 3/4. And since it's slope, I'm going to put the x next to here. Now the y-intercept doesn't affect whether they're parallel. So this one has a -5, this has a +1. I'm just going to put a different number. How about +3? Okay, because it has the same slope, it should be parallel. But now let's graph it to make sure. So because I picked my y-intercept to be +3, I'm going to go up to +3. And then my slope is up 3/4. And I'm going to draw my line. And when I draw it, it looks like it's parallel because it's running the same direction as these other lines. Okay, let's go ahead and try it on the next one. You might want to pause the video and then try it on your own. Okay, if you already finished, that's great. I'm going to go ahead and graph them. So y equals -2x plus 5 is up here. The slope is down 2/1. Okay, now the next one is y equals -2x. The y-intercept 0, 0. The slope is down 2/1. Okay, now I want to write the equation of another line that's also parallel. If they're parallel, they have the same slope. So let's look at the slope. Well, this had a slope of -2. This had a slope of -2. So I just have to make sure this has a slope of -2. I'm going to put an x to show its slope. Now the y-intercept can be whatever I want it to be. This one had a y-intercept of 5. This has a y-intercept of 0. So I'm just going to pick a different number for my y-intercept. Maybe I'll make it -3. Okay, now part C, graph the line for the equation you wrote. So I'm going to go ahead and graph this line. Okay, since my y-intercept is -3, I'm going to go down to the 3. My slope is down 2/1. Yours might be different, and that's okay. But when I graph my line, it should look parallel to the other two lines. And they really do look like they're all going the same direction, so that's a sign I did it correctly. Okay, now sometimes we don't graph them, we just write the equation of the line that is parallel. Okay, so I want to write the equation as parallel, so I want it to have the same slope. So for this one, maybe I'll make it say 2/3 x. And I can put any y-intercept I want. Maybe I'll make a 7 this time. Okay, go ahead and try the next ones. Pause the video and then unpause when you want to see the answers. Okay, go ahead and check your answers. Now remember, our slopes have to match, but your y-intercept could be different than mine. Slopes have to match, but the y-intercept could be different. Okay, check your answers and then go ahead and check the next page. Okay, now we're going to look at perpendicular lines. So these are perpendicular lines. I'm going to graph them, and then we're going to look at them to see why they are, in fact, perpendicular. So for this one, the y-intercept is +1. My slope up 3/4. Okay, I'm gonna graph the second one on the same coordinate plane. So this is a positive 2. Okay, sorry, I answered my phone. Okay, what is it? My y-intercept is positive 2. And then I'm gonna go down 4 over 3. And I'm gonna go ahead and graph this line. Now these are definitely not parallel. They make kind of a cross. They actually should make a perfect cross. See how they make that nice cross? And they actually meet at a right angle, which is a nice corner. So perpendicular lines intersect at a right angle, or they make a perfect cross, a perfect corner. Okay, now parallel lines had the same slope. Let's look at the slope here. So this one is positive 3 over 4, and this one is negative 4 over 3. So actually, they are not the same. They're different in every way. Since the first one was positive, the next one is negative. So they have to have opposite signs. And then the other things, this was 3 over 4 and this was 4 over 3. So then they also have to have reciprocal slopes. Okay, and that will make a line perpendicular. It will make it run perfectly at a right angle to the other one. Okay, so let's look at these. It just says write the equation of the line that is perpendicular. And make sure you read the directions because sometimes it says parallel, sometimes it says perpendicular. Okay, so let me look at the slope here. Since this is a positive 2 over 3, I want this to be negative. Since it's 2 over 3, I'm going to make it 3 over 2. X. Now the y-intercept doesn't matter. It just puts it somewhere on the graph. So I can put any number I want there. Okay, if you feel good, you can pause it. If you don't feel good, let's keep going. Okay, now the slope is negative 7 over 3. Since it's negative, I want it to be positive. Since it's 7 over 3, I want it to be 3 over 7. I keep the x on it, and then I can put any number I want at the end. How about a minus 4? Let's keep going. Okay, this is positive 1 over 4. Since perpendicular, I got to make everything opposite. So since it's positive, negative. Since it's 1 over 4, 4 over 1. Any number I want at the end. Okay, you could also make it negative 4x minus 10. You don't need the over 1, but I like the over 1. Okay, last ones are the same, but they're trickier. Okay, so let's see. This is, I'm going to make it a fraction because when I do reciprocal, it will be helpful. Since it's positive 2 over 1, I'm going to make it negative, and I'm going to flip it. 1 over 2. And then any number you like. Okay, let me make this a fraction. Negative, let me make it positive, 1 over 3. And then any number you want at the end. Okay, what is this? This is a 1 over 1. Since it's positive, I'm going to make it negative, and then 1 over 1 is still 1. So you can leave it as 1. You could leave it as something. What else? This is a good answer like this. If you want to write it in like a nicer way, you could write y equals negative x plus 2. Okay, go ahead and try the practice problems and then check your answers with the link on the calendar.